impressed with the results so far, but I'll get to that later. For people who never watch my other videos and have no idea what is so special about this octocopter, for me at least, I'm building my own multi-copter flight controller. So not using multi-wii or anything like that, but create the whole thing myself. So that includes hard and software. 2 years ago I started to build a Arduino flight controller as a winter project. Now within minutes I was addicted to it. There was and still is so much to learn and to discover. I mean, the possibilities are limitless. So don't forget to click subscribe and keep following me as I further develop this flight controller. Now the base plates of the octocopter are made of plywood. No carbon fiber, just good old plywood for this first concept version. When all said and done, I can always make the frame parts from carbon fiber material. The octocopter arms are 16mm thin-walled aluminium tail booms that are used for the T-Rex 500 helicopter. And as you can see, these booms really can take a beating. Okay, back to the octocopter. I automated my Proxxon milling machine so I can easily make these arms without any errors. By hand it took me ages and it was so boring. As you can see, I inserted a piece of wood in the tail boom. Before inserting, I dried the wood in an oven, causing it to shrink so it fit nicely into the tail boom. After placement, moisture from the atmosphere is causing the wood to swell, making it fit really tight and secure. After mounting the motor and feeding the wires through the center of the arm, it looks like this. Now the motors that I use are Cobra 2208 1200 kV motors with an 8x4.5 inch prop. Now here you can see the length of the boom compared with a DJI 450 flame wheel arm. Without screws, the DJI arm and motor are 109 grams. The complete arm for the octocopter weighs only 89 grams, so I'm pretty pleased with these arms. Now the arms can be mounted between the base plates. With all the arms in place, it turns out to be a very strong and rigid frame, despite the fact that I use plywood as a base material. For this octocopter I used these DJI 30A ESCs that I had laying around. But before using them, I flashed them with the BL Heli software to get rid of that annoying 8 kHz high-pitched sound. These power distribution boards, by the way, are round milled plain PCB boards. Simple and effective. I milled back the outer and inner edges to create more distance to minimize the risk of a short circuit. And this is how it looks after connecting all the ESCs and 2 battery connectors. Now I'm pretty pleased with that. Now it's time to mount the flight controller. First, a fiberglass plate is placed to protect the bottom of the flight controller from the wiring. A sponge is used to protect the barometer from unwanted turbulence or light. And the flight controller is placed on top of the sponge and fastened with plastic 15mm standoffs. Now I can connect the telemetry transceiver the Futaba S-Bus receiver, ESCs and gimbal signals, external LED, and the main power connector. Next is the navigation board. This board filters the GPS data and sends it to the main flight controller via I2C. And finally the Microblox LEA 6S GPS module from Microcopter. And that's it, the octocopter is now electrically ready for the first flight. All props, of course, are balanced to minimize vibrations. Just to get started, I copied the settings like PID, altitude control, GPS and so on from a much smaller quadcopter to the octocopter. My guess was that this might give a good starting point. After that, I tested the controls and the controller response by holding the octocopter firmly in my hand. And it felt good enough to give it a first try without the landing gear. Now this is the very first flight that I made with this octocopter. And I flew this in auto level mode. And I was really amazed by the way it flew. Even with the quadcopter settings, the octocopter felt locked in and very responsive without any overcompensation. So I must have done something right with the control algorithms. Feeling brave, I went to the field and flipped the GPS hold switch. And with the settings of the quadcopter, it flew like this. Now I think that is a pretty nice result. With the GPS working correct, I can now show some of the features that I programmed. With this telemetry transmitter I can store positions and upload them later on to the flight controller. To make things more convenient, I made an auto start function so I don't have to switch between the transmitter and the telemetry transmitter. Just start the multicopter with a key sequence and send the multicopter to the designated waypoint to take a photo or video. When the stick on the transmitter is pushed forward, a virtual GPS path is created. The multicopter will follow this path and automatically compensate for any disturbance like wind or turbulence. So the pilot does not have to worry about wind or anything. Just push and go. And I can tell you that my 4-year-old son really likes this feature. Now the multicopter is approximately 50 meters away and I'll switch off the transmitter to simulate a transmitter failure. If the flight controller is in manual mode, it will automatically enter GPS hold mode. There is an alarm and the multicopter will gain altitude and automatically fly back to the home location. The nose of the multicopter is rotated in the same position as it was on takeoff, so the pilot can recover the multicopter more easily after the transmission is restored. At the home location, the multicopter will automatically land and disable the motors. Now I don't know how strong this wooden frame is, but I don't want to take any risks at this point, so I will turn on the transmitter just before the multicopter lands. Being distracted by this bug, I almost forgot to switch on the transmitter. Phew, and that was just in time. Now you don't see that every day. With an octocopter, you have ESC and motor redundancy. If one ESC or motor fails, the octocopter will keep flying. Of course, it's important that the remaining motors can handle the payload. It's a little less stable as you can see, but even in these windy conditions, the octocopter can fly autonomous without any problems. To finish this video, I'll show you some footage that I got with my old GoPro Hero 2 and this cheap-ass 2-axis gimbal that I bought on Deal Extreme. The booms will be visible, so you get an idea of what the octocopter is doing during flight. Now €53 with shipping included. That's not bad. Now don't forget to subscribe if you want to keep following this project. So thank you for watching and see you next time.